Prova. Ci siamo. Vi lascio l'apertura con i saluti istituzionali. No, alla fine no. All'inizio sì. No. Vabbè, dai. Dopo ti dico.
Bene, bene.
Bene, benvenuti a tutti. Vi ringrazio di essere.
Welcome, good morning. Thank you very much for participating in the final event of the 5G Carmen digital corridor for the mobility of the future. We are slightly late, so we will start straight away with the institutional addresses with the councillor from the province of Trento, Achille Spinelli, and Francesco Profumo from the Bruno Kessler Foundation. Good morning and welcome at the Brenner. I represent here the autonomous province of Trento, and it is a pleasure and honor to be here today and to evidence the will of this province to look at the future, look at the usage of technology in the light and in view of innovation, and specifically digital innovation, which has always been a driving element for our administration. Also in terms of investments, in order to have a pragmatic and visible development of technologies that can be helpful in our daily life. Being here today for the digital corridor is indeed one of the examples of this activity. We believe strongly in it. We believe strongly in it for our province, for our region, for mobility of the future, for the environment, for safety, of course. We need to invest in these elements, and this project is indeed something that testifies to this will and action. I'm very happy that the Bruno Kessler Foundation, represented here by Francesco Profumo, but also by engineer Simoni, has joined effort in this project with a number of entities with a view of enhancing the value of the work. It is an international project. The Munich Bologna corridor is the corridor we want to work at and on, because it is the future. It is what really gives a positive vision of the future for the next generations as well. We are doing something which is correct, and we're doing something which is good for the next generations as well. So congratulations on what you have achieved so far. I'm sure that the future will continue bringing fruitful results. Let's continue working together to achieve those results. Thank you very much. Good morning. My name is Francesco Profumo, and I here represent the Bruno Kessler Foundation, which has been the coordinating partner in this important project, which has made it possible to create the conditions to anticipate a number of things. You see, back in 2019, the President of the European Commission, newly appointed von der Leyen, started her speech talking about transitions. I remember that we were working at the very same concept, and we underlined the fact that this was a valuable digital transition and transformation, but not only that. because we wanted to make up for the lack of a corridor in the south of Europe, which was otherwise present elsewhere in the European Union. At the time, we managed to set up a very solid, robust partnership coordinated by a research entity, which is, again, the Bruno Kessler Foundation, and that was a significant achievement. So actually, we anticipated what the President of the European Commission voiced in her speech about ecologic transition, digital transition, and a number of elements that have been at the focus of our project as well. After a number of years, we realized that transitions actually unite into one transition only. You need to have environmental, ecological transition in addition to digital transition. And of course, there is a focus on skills, which is the third element of transition, which is social transition. I would say that this project, which is a research project, which takes place within the framework of Horizon 2020, today has gained in importance and in significance. This has laid the basis for the possibility to move from research to an infrastructural project. So these are the major successes achieved by the new Europe, which sees in research projects which can be sustainable over the course of time, and that means that they do not end with the end of the project in terms of its financing. The Bruno Kessler Foundation, of course, expresses all its gratitude to the province, and not only the province, but to all actors for what has been done. This is indeed the example of a major project which has achieved the results it has achieved thanks to the joint activity that has been deployed with one objective in mind, which was that, and is that, of reaching a development model that should be something that we can replicate and, of course, implement. I would like, again, to thank the Autonomous Province of Trento for supporting us so much in terms also of supporting the idea that research is fundamental to create conditions for development. This project testifies to that. We have created skills and competencies. We have given the possibility to young people to test what they could in relation to these important topics. And we feel stronger today in terms of research and in terms of the idea of a project that can foster development starting from research. Thank you very much, and enjoy the day, of course. If I may, I would like to add something. We are hosted by A22, Autostrada del Brennero. So we thank very much Engineer Costa and A22 for hosting us, for the work that they have always evidenced in terms of being always on the cutting edge in terms of innovation. So we have yet another example. I also would like to add something, because you see, at the beginning of the project, in the very initial phases, of course, we talked extensively with Brussels. And initially, it was not clear what the final shape of our common endeavor would be. And the participation of A22 was the element that triggered all the rest, because the fact that there is such a heavy traffic, which is also polluting today, was the element that we wanted to focus on, because it is something that is in line and is actually a trade union in relation to the three transitions that I mentioned earlier on. So thank you very much also on my part to the A22 for participating. Thank you very much. Thank you for sharing your remarks with us, Before introducing the first speaker, Jorge Pereira from the European Commission, because Mr. Spinelli and Profumo have recalled the fact that this is an international project on the Munich-Bologna corridor. Before giving the floor to the first speaker, we would like to show to you a video about 5G Carmen, which shows the various cases and the results that have been achieved in the past 3 years and a half.
Automated driving will transform the notion of mobility. Commuting hours will be enjoyable and safe experiences. And our environment will benefit from decreased carbon emissions. This groundbreaking EU-funded project leverages on the 5G communication technology to connect all vehicles and facilitate their cooperation, including connected and automated vehicles in the communications network. With a dedicated 600-kilometer corridor between Munich, Innsbruck and Bologna, 5G Carmen will promote a cooperative transportation system which can be replicated throughout the EU in liaison with other activities on 5G corridors. 5G coverage has already been deployed along the borders of Italy, Austria, Germany, which accommodates 80,000 daily transits. Full 5G coverage is planned for 2025 and will pave the way for the creation of a fully equipped 600-kilometer 5G smart vehicle corridor. To support its 5G Carmen use cases on connected and automated driving, 5G Carmen has deployed an architecture where vehicles can communicate with each other through vehicle-to-vehicle and vehicle-to-network communication technology, exploiting the 5G technologies deployed for the project. Through the 5G network and directly among vehicles, data collected by vehicles can be delivered to the different services hosted on the Mobile Edge Computing (MEC) platforms. These platforms have been deployed with dedicated connections to minimize latency, thus bringing services close from a communications point of view to their users. The services in the MEC platform interact to provide the cooperative and connected autonomous mobility use cases piloted in 5G Carmen. These services are managed through an edge orchestration platform developed inside the project that also handles service continuity by speaking with other MECs in neighboring countries. In this way, services running on MEC of neighboring countries can be coordinated, and information collected on one side of the border can reach the other side through 5G connectivity, allowing service continuity across countries. Moreover, the 5G mobile networks in the 3 countries have been enhanced with some evolved features, introducing fast network reselection to reduce the communication gap when crossing the border, and local breakout to keep communication latency under control, also when users are in roaming. Lane merging is a cooperative operation among the vehicles, done every time 2 lines merge into one. 5G Carmen has deployed a centralized service to coordinate lane merging, optimizing it to avoid congestion or even accidents. In order to have all necessary information for the system to work, an onboard software inside the car obtains several information and then sends it to the MEC via a 5G modem. In our case, the data is their speed, position, and the blinker status. After reaching the 5G node of the mobile operator, data will travel to the MEC. We have 3 MECs, 1 per country. Each one consists of several elements that allow the coordination of the traffic. Advanced Message Queuing Protocol Broker allows fast and reliable communication between cars and MEC. It permits messages to be delivered to multiple services. The Service of Local Dynamic Map, SLDM, processes the received messages, combines them per geographical zone using quad-tree approach, and summarizes the requests of all relevant cars. The maneuvering service is the protocol that, with the info received previously, calculates the next actions for every car in the area. It coordinates their velocities, ensures that correct distance is kept, and allows space for a possible merge. The response router gets the coordination information and it separates it in messages for each car. Afterwards, the AMQP broker handles the sending of all messages to the receptive cars. The message arrives now to the cars involved in a merging. The speed from the two cars already in the highway is modified according to the information received, and the third car can safely merge in the most optimized way. This service allows a high reliability for zero-error lane changing and is capable of handling high vehicle density. The cooperative lane merging assist is but only one of the possible uses for this system. In 5G Carmen architecture, connected vehicles share their information with both CV2X direct communication and using 5G technology that connects them with the MEC platforms deployed in the 5G Carmen infrastructure. Services in the MEC can merge the information collected from all connected vehicles with additional data information provided by road operators about traffic or specific road conditions, building a detailed and reliable representation of the context around each car. Through 5G, this context can be delivered to connected vehicles to extend their perception and provide awareness of events that are still beyond the visibility of a vehicle's sensor. This follows a core principle of autonomous driving. In high levels of automation, a car needs to see beyond other cars. 5G connectivity, with 5G Carmen, is the solution to see beyond what sensors and individual drivers see, ensuring comfortable travel in any situation. For example, car following with the so-called extended perception ensures smooth speed adaptation in case of slowdown maneuvers or cut-in by other vehicles. 5G Link is supported by CV2X direct connectivity to ensure redundant communication between cars. In another example, when an emergency vehicle approaches, it can alert all preceding vehicles by communicating with services in the MEC. 5G Carmen promptly informs all road users along the corridor through its 5G infrastructure. Cars can automatically check free road space and change lanes, giving way to the emergency vehicle as it approaches. The 5G Carmen project will contribute to the evolution of connected and automated mobility in Europe. The 5G cellular network infrastructure, the 5G direct communication technology, and automated driving will transform the future of cooperative transport, making the EU a leader in the reinvention of global transportation systems.
Benissimo, grazie a tutti.
Thank you very much. I apologize, but I forgot to tell you that there is a simultaneous translation for translation into English and Italian if you need, and that is needed also for the speech by Jorge Pereira.
Can you hear us?
Yes, indeed.
Perfect. Okay.
Can
Thank you for being here, Jorge, and welcome to the final event of 5G Carmen. Okay, perfect. We are seeing your slide. Please go on. Thank you.
Okay. Thank you so very much. First of all, my sincere apologies for not being there with you. Unfortunately, due to an unforeseen conflict with our evaluations, we are evaluating now not only the SNS, but also the CEF2 digital 5G corridors, it ended up not being possible. So again, my apologies. Let me briefly address 5G for CAM, 5G for Connected Automated Mobility, in this final public event of the 5G Carmen project. You have already seen a compelling video of the achievements of the project. Very well done video indeed. But let me highlight the European policies underlying the 5G for CAM focus and also the next steps. So let me move forward. The European Commission launched in 2016 the 5G Action Plan, which was approved by the member states with concrete goals in terms of trials and early deployment of 5G towards pervasive coverage by 2025, focusing on where people live and in major transport paths, and now full coverage by 2030. In the telecom package of September 2016, there was also the European Gigabit Society, besides the 5G Action Plan, and there it was recognized that 5G requires broadband in terms of pervasive fiber availability, while also providing broadband. And this will be then emphasized again in the new focus. As a response to the crisis generated by the pandemic, the Commission reassessed the situation and established even more ambitious targets for 2030. So by 2030, all European households will be covered by a gigabit network, with all populated areas covered by 5G. So again, here 5G is part of the broadband delivery. And at the same time, by 2030, there will be pan-European deployments of 5G corridors for connected automated mobility and advanced digital rail operations, contributing both to road safety and Green Deal objectives. The 5G Action Plan, the revived 5G Action Plan, has now a longer-term objective under the Digital Agenda for Europe to achieve 5G everywhere by 2030. This requires an even more aggressive rollout with broad geographic and sectorial focuses, but mainly addressing the least covered, least populated areas. But why 5G? 5G is seen as a critical tool to deliver connected automated mobility by allowing increasing levels of automation, but also by ensuring seamless service across Europe, even across borders. But why the focus on cross borders? Because these are the major challenges. The Commission singled out this aspect because in urban areas, the market will deliver through strong competition, but that in remote areas, market might be too slow to act. So the investment was needed to address both the difficulty of the areas and the technological challenges associated with continuity of service, but also to make sure that we can address the market failures in these regions. Let me now focus very briefly on the 5G for CAM cross-border corridors, which were represent a major effort to prepare the grounds for the subsequent deployment of 5G for CAM across all major transport paths. This picture shows you the still ongoing projects, both from Call 1 and Call 2, across the trans-European transport networks. We see in white the projects from Call 2, and in red the projects from Call 1, and 5G Carmen covers, as it was mentioned, the corridor from Munich to Bologna. Okay, focusing here now on the border areas in these countries. So the projects constitute a good sample of the trans-European transport network and allow us to address specific issues and specific difficulties that have to do with regional and local characteristics in terms of deployment and availability of technology, but also in terms of the involved players, okay, which go beyond the MNOs, the operators, to include also the vendors, car manufacturers, but also the road operators and road authorities. We invested in these two calls over 105 million euros to address, as I said, the specificities and difficulties of these cross-border scenarios. On the way towards 5G everywhere, we have invested, as I said, 105 million euros under Horizon 2020, but now we aim at covering the full train transport network by 2030. For that, we are going to invest around 1 billion euros under CEF2 digital 5G corridors, to which you have to add additional public funding sources, both from regional and national authorities. But besides that, private investments will be essential to cover these areas. Remember that what the Commission intends to do through the CEF funding is to facilitate, to accelerate deployment in these areas where the market, as I said, has problems, where return on investment will not allow the operators to deploy as fast as we would like to. So, in conclusion, in order to enable and empower 5G for CAM, we are going to need to continue to have these distributed test beds, which the cross-border corridors constitute, to allow us to check the issues and problems that arise. As I mentioned, towards this 5G everywhere, the Commission has already invested over around 150 million euros in 5G PPP, 105 in the cross-border corridors, but also 45 additional million by other projects dealing with advanced mobility. And we now want to move towards, in the context of CEF2 digital, to the actual deployment of 5G corridors, and we are putting there 1 billion euros. There are still many challenges ahead. CEF2 digital focus on deployment, but we want to continue investing in research in this area under the new framework program, the 6G SNS activities. And with that, I leave you to your meeting, and but I remain available if there are any questions. I will be here. Thank you so much.
Thank you, Jorge. Thank you a lot. Ritorniamo all'italiano.
Let's switch back to Italian. So we have here with us the CEO of Autostrade del Brennero, Mr. Diego Cattone. We are glad to have him here with us, and I'd like to thank him for hosting this meeting here in this nice facility. Thank you. So I'd like to thank Councillor Spinelli and Mr. Profumo. I'd also like to welcome all participants. So this is a very hot topic today, also considering the level of traffic there is at the moment on the motorway. So so now we are driving in an analog fashion, and we decide when to do things. It is an imperfect order because it is based on personal decisions. So it is an incomplete order. Switching to a digital system, managing traffic in a different way, in a more efficient way, going from an analog organization, an imperfect system, to a much more perfect system. then of course this is a great solution, also considering also how much to the extent that traffic impacts our lives every day. So I will talk, so this is something that impacts the Italian system, also Autostrade del Brennero. Some days ago, there was a meeting in Lisbon, ASACAP, the European Association gathering all European operators. Italian ISCAT so is a member, and we are members of this latter organization. So there are many, all European countries are members, all Europe up to Russia. So digitalization, this is something which is being discussed everywhere in Europe, so a sensitive topic, and Italy has a leading edge here, so especially compared to other countries, because we have projects that have already been implemented, whereas in other European countries, well, we are seen as a benchmark. We are very much admired. In Italy, we have the Brennero project, and Brennero is a leader, an innovator in a way. So we are discussing 5G, this small latency, almost non-existent, that enables autonomous driving, makes it easier. So this is a really hot topic, and I'd like to conclude my introduction by reminding you that these are themes being discussed in Brussels, and also Brennero is putting a lot of energy in this. So there is, we have know-how and the willingness to, make these future projects a reality. We are there. We are investing our knowledge, our money, and we are very determined to do something for the transnational corridor, for the country, for Europe. Thank you so much for your attention. Well, let's now have a look at the main results, outcomes of the 5G Carmen project. So I will make the presentation together with Roberto Fantini team and Filippo Visentano from Stellantis.
Okay. Okay.
Well then, I will introduce very briefly the 5G Carmen project, and then Mr. Visentano from Stellantis and Fantini team will give an overview of the main results of this project. Okay, so what is the goal of the 5G Carmen project? So it wants to harness the concept of mobility corridors, that is, corridors for future smart mobility to move people and goods across Europe. So 5G will be used as an enabling technology to make this new concept of connected and automated mobility a reality. So the vehicles will no longer be something used to move from A to B. They will become a smart environment to meet the requirements of the 2030 European Mobility Plan. So the Bologna-Munich corridor has a total length of 600 kilometers. It connects two major industrial areas, Munich, cities Munich and Bologna, and it runs through the three countries, Italy, Austria, and Germany. So This project includes national test sites and 2 cross-border test sites. We have tested there the technologies used in our project, which are here. The sites are here at the Brenner and close to Kufstein between Austria and Germany. So this project, well, is supported from the Regio region, from UCAR and the innovation system of the Trentino region. So FBK, project coordinator, together with Deutsche Telekom as a technical manager, have contributed to this project. So a lot of competencies and skills were necessary to make this, to develop this project. So 25 partners from 10 European countries, and then the Bruno Kessler Foundation, University of Bozen, and then car manufacturing companies, Stellantis, BMW, for example, and telecommunications companies such as TIM, Deutsche Telekom, Magenta, and also other organizations that have contributed to the project infrastructure. So the project will end in July this year. Total cost 19 million euros. So what is the idea from which this project stems? So we want to have connected vehicles that are both in the digital and physical world. So we have an object, they become, evolve from a vehicle to move to a connected vehicle. So these vehicles use the 5G ready platform and uses, supports the automotive system. So safety is very important here. And these are just a few figures. So fatal car accidents, for example, the first one, and then other types of accidents on motorways. And it has been demonstrated that autonomous driving is much safer and can help avoid accidents and hazardous situations. In particular, this project provides a platform where vehicles are able to exchange information on speed, position, intended trajectories and maneuvers to, enable automated and safe maneuvers. So in addition, normally drivers are limited in their ability to perceive the surrounding environment. And another important achievement of this project, 5G Carmen project, is that it provides an extended perception of the surrounding environment, so vehicles and the infrastructure can share the perception of the road. Thank you, Matteo. Okay, good morning, Roberto Fantini, team. So, in order to achieve these goals, the first problem we had to face as a carrier was to provide 5G coverage. Of course, this coverage was provided by TIM in Italy, Magenta in Austria, and Deutsche Telekom in Germany. So we cover some parts of the corridor and then cross-border areas, for example, Kufstein and here at the Brenner. So what I'd like to stress in particular about this coverage is that it is based on the commercial network. I'd like to say this because this gives you an idea of the difficulty of deploying the various scenarios on a commercial network that has to support users. They are paying to use this network after all. And then also, I'd like to stress the fact that what we will see today is feasible already with the networks we have today in place. It is feasible, of course, with some enhancements, of course. So we had to optimize, introduce some optimizations, because, we know that there are problems when you change operator. You move from one country to the other, you change operator, so you have to be able to support with the network challenging scenarios. The first problem is when you cross the border. When you cross the border, then you leave the national operator network, and then smartphones start searching for the new operator. This process can last some seconds. So, for example, at the beginning of the project, we had even gaps of 96 seconds, and you see this on the left-hand side in the black part. So areas where there was a disconnection. And this is not acceptable for this scenario. So with the help of our technology partners and through a close cooperation and information exchange with all other carriers, we have found the solution, the fast network reselection. What does it do? It accelerates the reselection of the network. So we have reached a level of lower than 1 second. So we have only one black spot, let's say, or you can see that below at the bottom of the picture on the right-hand side. The impact on the network, of course, is much higher, and this is not possible, of course, cannot be supported by the existing commercial network. And then when you are in the new country, you start your roaming, of course. The connection is a roaming connection. When you are in roaming mode, then data and traffic is always sent back home, so routed home. If you have an Italian SIM and I'm in Austria and I want to connect to an Austrian service, then my data goes back to Italy and then bounce back to Austria. This is a problem for latency. What is latency? The time a data package takes to cross the network, to go from the vehicle to the server it wants to connect to. If the packet goes to Italy and then comes back, then it takes time. At the beginning, latency was hundreds of milliseconds, too much for an automotive scenario. So working with partners using features that are already there but are not usually deployed for practical reasons, tariffs, rates, and legal and privacy. We have introduced a local breakout. It sounds like a bad word, but what does it do? It enables traffic to remain in the country it is generated in. So if I'm in Austria, traffic stays in Austria. It doesn't go back to Italy. So the latency time are more acceptable for a commercial 5G network, below 20 milliseconds. So I work for a carrier, so I don't want to tell you all that we had to do to make these services possible. So we have created a quite complex architecture that you see streamlined here in this picture. I will not go into detail as to the various boxes that you see. We have the vehicle talking to one another and talking with the 5G network. We have the 5G network, and then we have the control rooms of the road operator, the A22 Brenner. And we have the green square. This is a new element, a very important one for the 5G network, MEC. It was mentioned earlier. The MEC or Edge platform, it is a server where you can host the project services. It was created so as to have very low latencies, so they are very close to where the service is deployed. So the our services reside here on the servers, but we immediately understood that MEC of the various operator carriers had to be connected to ensure service continuity, because that was the big challenge of this project, demonstrating that I can be in Italy, I can interact with the Italian MEC, I have the service, but when I go to Austria, then the service comes with me. It is managed by an orchestration platform that moves that service from the Italian server, MEC, to the Austrian one, so that the service stays with me and still gives me localized information and relevant for the area I'm in. So, and that's all, and I'd like to hand over to Filippo, and he will, tell us what this means in practice. My name is Filippo Visentiner, Stellantis CRF, and I will tell you about the demo you are going to see. The demo tells you what we have been doing for months now on a cross-border level. Across the border is a challenging environment. If you think in terms of autonomous driving, that has to be supported by connectivity to have higher levels of automation, so that you have a full understanding of the environment and obstacles represented by the vehicles and surrounding the vehicles and your vehicles, so that the vehicle carries out all maneuvers automatically, and to make sure that it can take all the decisions needed to manage unexpected events. This is what we define a high level of automation, so managing unexpected events. So the vehicle needs to be able to understand what is happening close to it, perceived by the sensors, but also what is happening mid-range, let's say, where sensors which cannot reach, because think of a camera, for example. An obstacle can be seen if it is close by, but a camera cannot see what is beyond a vehicle. So 5G and communication, vehicle-to-vehicle communication, enables a support, makes it possible to support the vehicle in this extended perception. And so in a cross-border scenario, you need to have continuity of service. There was a gap, but it has been bridged. Is for this reason a challenging environment. If you have brakes, 1 minute, for example, autonomous driving or assisted driving can no longer benefit from a perception beyond the sensor range, let's say. So we are going to show you our prototype vehicles. BMW and the partners are testing also these situations, also these scenarios also in Kufstein. So the demo will be referred to the Brenner era. So you will see vehicles connected to the 5G network, and then you will see what we did in terms to guarantee redundancy of communication. So we have automated sanction level 4 and level 5 automation. So these features and functions enable you to manage unexpected situations, unlike 3D automated features and functions, because the 3D level, has an automation that has to be supported by human intervention in unexpected situations. So level 4 and 5 is a higher automation, but it needs redundant channels. So there is a communication with the 5G network, but if there are fractions of seconds where you do not have a network 3 seconds reselection, there is still a communication between vehicles. This is a redundant channel, which is essential for automation. And then there is the user interface, of course, that enables you to have a general overview of the situation. We can show automated features. Well, of course, we are on a public road. Some function concerning lateral control will be supported by the driver. So the driver will be supported. The driver will be given an advice. So this is a high-level overview. So we have the onboard unit, the V2X unit integrating the 5G module. It is a direct communication module. This was developed by Qualcomm. We have a service that is enabling high-precision localization of the vehicle, because it is important to have a precise positioning of the vehicle in the lane where the other vehicles are as well. And this was possible thanks to Deutsche Telekom using 5G Carmen network. And then we have the module developed by Stellantis CRF, the prototype unit, enabling using a combination of sensor-based data and connectivity-based data enables the longitudinal control and lateral control of the vehicle. So the main concept that you will see in the demo is extended perception. Extended perception, well, is enabled by the vehicle sensors, and this is state-of-the-art. You have the radar unit, the camera, and then also through communication, so the other equipped vehicle or vehicles will provide their information on their trajectory, position, and speed. And then this is the real what makes the difference. Why this project makes a difference. So the other vehicles. Trucks, for example, non-equipped trucks or non-equipped vehicles, pedestrians, for example, because also in parking lots, for example, are perceived by the preceding vehicles when we don't see them, and the information is transferred to the vehicle following. So you have, thanks to the 5G, the same data transmission frequency than the frequency of the updating for sensor perception. So if the sensor perceives 20 times per second an obstacle, then the 5G transmits this information 20 times per second. So the vehicle behind can see, let's say, perceive the obstacle, which is very much ahead with the same frequency. So the 5G, thanks to the 5G, communication is no longer a bottleneck for data transmission. This is the real added value provided by the project, by the 5G technology, and which we will see today. So during the pilot, we will measure this performance or in terms of vehicle perception, and we will show you some applications and we will see that thanks to this extended perception, vehicles can a smoother speed profile, can perceive other non-equipped vehicles, because not all vehicles will be equipped with this connectivity technology in the near future, so they are able to perceive the trucks very, very far away. And they will also be able to leave space for merging vehicles. These are the use cases, well, lane change and lane keeping in a cooperative, adaptive cruise control function feature, a feature that enables, keeps the safety distance from the preceding vehicle. That's all.
Perfetto, grazie. Continuiamo con...
Wonderful. So we now continue with a contribution by engineer Carlo Costa from Autostrada del Brennero. He's the General Technical Director at A22. Good morning also on my part. It is still morning. Good morning. So this is a very useful opportunity to present to you the investment made by Brenner in relation to the vision of the future. We think in terms of a motorway, which is on the one of the most important corridors in between the center of Europe and the Mediterranean area. The infrastructures were created 50 years ago, 30 kilometers of viaduct and many tunnels from Bolzano to Brenner. And this makes it clear how complex the situation is. It is not simply a question of building new roads or motorways. It is much more complex than that. In addition to that, there is also a cultural element to be considered, because here you see the fleet in 2019 on A22, and Italy is the country with the highest number of vehicles per number of inhabitants in Italy. And you see that we have increased by more than 115 times the number of cars in Italy in the past 70 years. We have 40 million cars now. What is our specific interest is the development of road transport, because we are used to the concept of planning our traveling options, but not when we drive a car. We know when we want to travel by train what we have to do, and the same goes for boarding a plane. We even buy tickets for cinemas in advance, but that does not apply to cars. We simply get in a car and think that we can gain access to all possible mobility offers straight away with no issues whatsoever. So this is a concept that has to be overcome and improved. We all come from this history, this past. In the past, cars were a status symbol, and this is no longer the case, should not be the case any longer. They should not be objects that you own, but something that you share. These are the elements that we have to work at in relation to managing mobility of the future. Now, with the 5G Carmen and also with other projects, we want to pursue precisely that goal. You see, there is some resistance against this type of testing in the world of mobility. The idea of moving from individual mobility as a system whereby we are all individually using our cars to an orderly and regulated traffic is something which is a major change. There you see ants, and I put that animal there because I want to symbolize the fact that we all move in one direction with the same goal. Digital mobility, on-demand and cooperative mobility leads to a better usage of the vehicle itself. You see, by now, all cars have sensors and systems on board which permit to receive and transmit information. The problem is that there are no platforms to collect and exchange and manage those pieces of information in order to use them at best. So the infrastructure will be key. The car will no longer be the focus, but the infrastructure will. In relation to safety and the environment, President Profumo earlier on said that these projects, in order to be supported by the European Commission, have to have a part which is specifically dedicated to the environment and to safety. And you see, we did very much in that respect, because we know that there are several aspects to be considered in relation to the environment, but also to the economy. The point always being that of having a win-win situation where the environment is preserved, mobility is facilitated, and everything runs smoothly. This is what the CITS system should achieve. In order to get there to these cooperative systems, what we need to have are a number of features, being, first of all, the fact that there is full coverage of the service, and what has been said earlier on about cross-border systems should be applied extensively. You have to have a seamless system, otherwise you will have a limitation that you cannot overcome. And this is something which should be generally provided. This goes beyond individual and vested interests of operators. In addition to that, we need to have free access. Only by doing this will we be able to achieve the results that we want to achieve. Here you have a number of figures. 1.35 million people die due to car accident every year in the world. It is a carnage. So it's unacceptable. 3,000 people in Italy only. You see that there is also the fact that roadworks make out a share of these accidents. These are accidents which are linked to the individual case, and individuals, single drivers, might be lacking attention in that moment, or they are poor drivers, and so they are responsible for many accidents. This is something which is detrimental for the system. The system has to try and counter that individual problem. We worked on that in order also to improve traffic flows, in order to reduce accidents, and in order to reduce the environmental impact. This is something that we did with our project, which showed that in the moment when you have cooperative processes, the accident rate reduces, the levels of emissions into the environment are reduced heavily, and also the duration of the travel is shortened, which means that we want to use more innovative technologies in order to increase the level of safety, and we want to also respect the environment and the areas. This, of course, fits very well with the 5G Carmen project, because the idea of having connectivity which can manage data at best requires that you have fiber along the entire section, and that is not sufficient. Actually, this project that I mentioned earlier on in relation to the management of data for individual vehicles presupposed already that you would have a digital motorway, and that you would favor the connection, which is what we did with short communication and long communication using different technology, including mobiles in the latter case. This is what we did. The 5G technology, of course, improves the overall process, makes it more reliable, so that we have a very low latency, so that we improve coverage, and we also make up in this way to make up for the fact that you deploy a technology which makes a cost feasible, and you have a seamless system, as I said. Another important thing, which is also part of our proposal for the renewal of the concession agreement, is the fact of having a platform which integrates different transport systems. We want in the future to provide a service which is simply effective, with no competition between one service and the other. We should not have a competition between individual mobility using cars and collective mobility in trains and on planes. We have to join efforts. This is indeed one of the ideas that we brought forward, the idea being that of having a motorway which is an intermodal hub. Having said that, I would add that this work that we have performed over the course of time always went in the direction of innovation. You are never sure about what you can achieve, of course, when you start, but unless you start making the first step, you will never get anywhere. Thank you very much. Thank you, Engineer Costa. We now continue with Mauro Boldi, who is responsible for the international projects at TEAM, and he will address us on the mobility of the future.
Buongiorno a tutti intanto.
Good morning. My name is Mauro Boldi. I'm in charge of European projects for the innovation in Europe.
Appunto, come detto prima, sono Mauro Boldi.
As I said, my name is Mauro Boldi. I'm in charge of European projects for the innovative sector or at Team Italy, and I will do without the slides. So I will speak off the cuff, and I will speak about the role that we have had in this project and the perspectives and prospects for the future in line with the project. But let's mention a few facts about our past. I started working at this project in 2018, when, thanks to the cooperation and collaboration with Mr. Profumo and with Engineer Bagnasco, at the time in charge of innovation, with Engineer Ferrigo, who at present is at Imueta. So with them, we started basically the project, and it was indeed an adventure. It was not easy. We know that starting the 5G Carmen project and then deploying it has not been easy. It was so because 4 to 5 years ago, the situation was very different from today. 5G was something that was part of the future. Now we're already speaking of 6G. At the time, 5G did not exist. We could not think of installing towers for 5G because there were no radio stations for 5G. Nobody had them, which gives you an idea about the extent to which 5G Carmen was a cutting-edge project. At the time, we had only the device-to-device option and field, which was very specific in standardization. You know that 3GPP is the entity behind this, and that made it possible to have mobiles calling each other without connecting to the operator network. Clearly, we did not like that very much as a company, while the V2V communication, not only within the framework of PC5, which is the communication channel connecting vehicles directly without using the network, that communication, on the other hand, was interesting for us as well. The 5G Common project made it possible for us to interact with the verticals, as we called them from the very beginning. What are verticals for Telecom Italia? They are the players that in the past years have harnessed the potentials of 5G, and that could not do that with 4G, simply because 4G was a radio mobile telecommunication system based on the broadband, which meant enhancing communication possibilities. And that was it. It was a success, indeed. The large and pervasive presence of mobiles and smartphones depends on that. 5G, as it was started basically 4 or 5 years ago, had as a goal the digitalization of the world, which meant for an operator, for a company such as ours, to interact with other players, different players, which would use new functions, which also includes low latency, which is something that previous speakers mentioned already. What does low latency mean? It means that you can have vehicles communicate almost in real time. The time range is a few milliseconds. If there is this latency, delay, basically, of milliseconds, we can then deploy applications that prevent accidents, that makes it possible to have smoother maneuvers, or even to tell the cars before you to activate your braking system. And I saw that yesterday. I had an anticipation of the demo, and I was really impressed. You will understand what I mean when you participate in the demo later on. For us, 5G Carmen has been an opportunity to make research with new players and to open up new markets, which are very important to us. Because by now, we are no longer the company that makes it possible for people to make a telephone call, but we are, as our previous slogan went, we went beyond connectivity. That was our slogan. This is what we actually did. 5G Carmen is not a connectivity project. It's not simply that we installed towers just with a view of having passing by vehicles be connected with to the network. That is something that could be done also earlier on. We did something else. We did something that was challenging, because you see, connecting two clouds, one being in Austria and Germany and the other one being in Italy, is something that simply was not part of our skills. It was something that we could not do until a few years ago. Thanks to the 5G Carmen, that has changed, and we are from now on, but also were in the past, interested in all automotive sector activities. We are in the C-Rose project as well, and we also tried to find a solution between the CDS and the 5G solutions over the years. And of course, we wanted to push 5G, also for the reasons mentioned by Mr. Vicentina, because with 5G we really have an implementation of the communications from vehicles to the network and vice versa. This is something that was possible only with the 5G. We do that with 5G Carmen, C roads. We will do that with the additional projects that will be made if this activity continues, also in terms of deployment on the 822 motorway, as we all hope, of course. So what you see is the outcome of a research project, which serves as a milestone, and it is also the starting point towards deployment and commercial deployment solutions for the forthcoming years. Again, I apologize for not sharing my slides with you, but I hope that my speech was interesting enough and especially clear enough in terms of explaining why TIM has been part of this project.
Okay. So now we have Mr. Marco Vassallo in charge of, Innovation Manager team, Innovation Team Manager for Stellantis. He will talk about 5G and the mobility of the future. Good morning on my behalf. And with my presentation, I'd like to tell you how we think that 5G technology can change the future of mobility. It is a future which is closer and closer. It is not as far from us as when the project started in 2017. And Mr. Boldi said that at that time we didn't have 5G technology. Thanks to 5G, then we could start with the project that could employ all the new the enhancements and so on. Well, now we are already talking about 6G. Maybe there will be a 6G Carmen project. So, as Stellantis, formerly Fiat Chrysler, we have always wanted to meet challenges arising from change, and now this changes are associated with electrification, pushed and driven by also from the European Union driven by the challenge of decreasing environmental impact, therefore giving up combustion engines, then automated driving and connectivity, of course, which is very important. Let's see how the first two interact with the third. So electrification technologies need to work properly, operate in all countries, and have to, of course, cater for the needs of consumers who are different from country to country. And connectivity enables companies to provide services that were not necessary in the past. For example, the possibility of recharging your car anywhere, or looking for the best route to save electric energy. So, and this has an impact on electrification, of course. It has a greater impact on autonomous driving. So so from L1 to L5, so this shift, this evolution has been made possible through connectivity. So the L3 system will be the first watershed between the all mobility and the completely automated mobility, and the hardware architecture and the software on board the car will need to enable complex maneuvers in a fully automated fashion, and also able to manage the car in emergency situations, unexpected situations where the driver cannot intervene fast enough. So the system has to drive the car, autonomously drive the car to the side of the road. So even at L3 and L4 level, we should try and implement this. Then, of course, automated system involve a higher complexity on board of the car, and also a higher complexity of the procedures to be implemented to validate the functioning, because of course, and you need to be able to test and evaluate what can happen in a high number of scenarios, and these are essential for the validation of the system, for validating the system. And such a complex system, of course, require a certain timing and costs that are higher than with a traditional car. This is a big challenge for car manufacturers. However, if we look at what the world is offering, well, you see that the internet is highly pervasive, and that new technologies are being invented and introduced. And so this enables us to offer products and services that are completely different than what was offered before. So even lower level cars now have connectivity that were unheard of some years ago. Even an A-class car is equipped with features as equipment that was unheard of some years ago. So connectivity enables this paradigm shift in mobility for mobility. So, and anything we do, even if you want to buy a train ticket or so you use connectivity, you use the networks, and this is something that will become more and more widespread in everyday mobility. So as to mobility in general, we certainly need that this mobility becomes more and more sustainable, because what we expect from the European or national regulators that will devise future strategies, well, they of course need will give they will give strategic guidelines to decrease the impact of mobility. And we will have to react to these guidelines, and we'll have, of course, to comply with the constraints of the new regulations. The 5G network offers unprecedented performance and features. I don't want to go into detail as to coverage level, speed of data transfer, and so on and so forth. Ongoing round-the-clock connectivity. These are considered now maybe seen as magic features, but what we have seen in this project, is that they can really be implemented and they can really have a huge impact on the mobility of the future. So, as somebody said earlier, this will certainly have impact on the efficiency of mobility in terms of energy consumption, but will certainly have a huge impact in terms of safety, because if you can have a car that, or a car that sees not only what the sensor perceives or the camera perceives, but what other vehicles on the road can see, well, this is a factor that will certainly increase the level of safety of cars and vehicles in general. This is what we have seen over the years with this 5G project. The partners' contribution, this is one of the advantages of European projects. So partners such as the Bruno Kessler Foundation, which was responsible for development, and then what we received from the A22 motorway. They provide the test bench, 600 kilometers from Bologna to the Brenner. So this enabled us to test the car on the road in a traffic situation. So a European project such as this one is probably the only way that enables you to have a large-scale testing phase before, of course, rolling out the system. So this is. So now the challenge is going from what we have developed in the test phase, in the lab, in on-road test, and move these to standard vehicles. So 5G is fundamental. Without 5G, this is impossible. It was impossible with the previous systems. This is why we are part of the associations such as the 5G Automotive Association, because, in our opinion, also associations that help standardize data exchange protocols should contribute. So without them, this would not be able, because we have to have a standard environment, and you cannot create a standardized environment just working alone. So I'd like to thank again the Bruno Kessler Foundation, the host for today's event, and they have really been a fundamental partner for this project. Thanks a lot. And it is a pleasure for me to introduce Professor Vito Mauro. He represents the representatives of the Minister for Infrastructure and Transport and Sustainable Mobility. Well, I hope you can hear me, and good morning. I'm sorry, but I couldn't come on site. So I would like to start by, bringing to you some greeting words from Minister Giovannini. So he could not take part in this event. And I'd like to really share with you my compliments for the work you have carried out. So this research activity, this coordination, cooperation activity has been fundamental for the future of mobility. So our role, the role of our ministry, so we are not the Ministry of Research. We need to be able to use the results of research work as timely as possible. What does it mean? And we will go back to this later. This means creating the enabling conditions so that innovation can really have effects and show its effects. And that's why we have been interested for some time now to see what the effects of mobility, of connectivity can have on mobility in general. We are interested in everything is being done at European Centre on the at the CCAM level. So cooperative connected mobility. Why are we interested in this? We want to improve the safety and efficiency of traffic and mobility in general, and we'd also like to improve resiliency of infrastructures. And we believe that all these technologies can really contribute to this improvement. I need to repeat some things that have already been said. We still have 3,000 deaths per year because of traffic accidents, and this number we are not do not manage to decrease it. So in the next 10 years we aim at halving this. So we were able to decrease this number in the decade between 2010 and 2020. We were not able to do it, and it will be difficult to decrease the number in the next decade, 2020-2030. So the Ministry of Infrastructure and Sustainable Mobility, of course, because of its name, has an interest in this. So we are really interested. So we want. So you were mentioning 2017 as the year where the 5G Carmen project began. In 2016, 2017, together with all national stakeholders, we defined the Smart Road Decree, which laid the foundations for the infrastructure digitalization, development, and digitalization of mobility. Then Decree 70/2018, laying down the main principles and decrees for the building of roads, and it created these observatory for transitions within the ministry. So I'm part of it. Something has happened, actually. Well, not all that we had hoped for, but you have mentioned all the experiences and tests made on the A22. The TS services, then this project, 5G Carmen project, which has proved the effects of the 5G when correctly applied to connectivity. In the decree, we were a bit too optimistic because we had set 2025 as the year where CSTS services would be active on nationwide, but in Italy, of course. But there is a delay. Some of you mentioned the conflict between the fight between the various technologies of 4G, 6G, and so on, 5G. But we already have some prototypes in this country, besides the Brenner one. ANAS has introduced the Smart Road project, so they are not so far away. So then the Alemannia road, then Cortina, then the Rome Fiumicino stretch, Fiumicino airport stretch. Then almost all operators, Italian road operators, have very ambitious plans in this area. So what can the ministry do then? What can we do? What do we want to do? We want to interact with everybody so as to create a playing field and the enabling conditions. And this means we need to understand whether laws, regulations are needed, understanding how we can, where we can direct funds. And we have the resiliency plan, the National Recovery and Resiliency Plan. There are some of these projects that will be funded with these funds require the development of prototypes at a national level. So it is the right time to start again this idea of the development of national service platforms for connectivity, in particular for CITS. Why are we so interested in connectivity services for mobility and traffic? Because all studies say that there is a 3-to-1 cost-benefit ratio or relationship, and especially diffuse costs. So the cost of infrastructure is not huge, so this is something that can be done and will be very useful. But we need to work together to do this, to accomplish something. We should go beyond this idea of locally developed prototypes. So we should really put in place a shared scenario that, of course, includes technological evolution, but something that also involves interaction, the understanding of business models, interaction models. For example, Vito Mauro is in his car and wants to use some services, and so we need to understand how this can be possible. So we should then share this scenario, have everybody understand this scenario, so that then various players can decide what to do in business terms, and so also central authorities will then be able to do what they can to facilitate these projects. So, for example, extending these platforms that you started creating with MACs and information brokers. We could see whether this is applicable at a national level. Maybe there can be, we should understand whether a contribution is necessary in terms of money, where so private companies cannot are not enough, do not have enough. So then competence, knowledge, skills, they are there. We are mature from this, a mature country from this viewpoint, but there are also opportunities are there because we do have pilot projects. Then we mentioned mass. Mass is a similar area. Even in mass, you need to focus on interoperability between various players, various private platforms addressed to end users. And there we are managing to create a minimum basis, because in the mass area we already have developed a project, but our ministry, together with the Ministry of Digital Transition, acts as an enabler and facilitators through the creation of the implementation of platform, B2B platform, for mass operators, transport operators, to ensure interoperability. So, to conclude, we are ready to support this effort. We'd like to do it together with all the various entities, bodies, and organizations involving the road operators, car makers, and the technical partners, so that we can include not only motorways but also the urban environment, the urban traffic, so which is a problem in terms of sustainable mobility. We hope we'll be able to create a framework to work together as soon as possible. Thanks to your efforts, and 5G Carmen is a beautiful example. Then we do have the skills, the tools, the prerequisites, and so we're ready. Thanks a lot.
Grazie mille.
Thank you. Thank you for attending and speaking to us. That was the last contribution for our meeting, because we now open the round table moderated by Marco Pistore from the Bruno Kessler Foundation. We then have Andrea Mondo from INWIT connected remotely, and Mr. Klaus Pahl from the Free University of Bolzano. Alessio Beltrame from the Ugo Bordoni Foundation is also a panelist. We were supposed also to have Giuseppe Neri, director of Swarco. Unfortunately, could not make it today. So these are the panelists. Thank you. Thank you, Matteo. I see that Mr. Mondo is connected. There you are. Good morning, or rather good afternoon. My task is that of being brief, if possible, so that you can have your lunch and then or participate in the on-the-road demo. So I kindly invite all speakers to be brief. We have received already so much information. Let's continue providing information, but without dwelling at length on things. The Bruno Kessler Foundation has had a very important role in the 5G, Carmen, and very happy to see the results of the project. The Digital Society Center has the task of bringing the digital technologies come to the communities and be part of the daily life of communities. And we have seen already so many things in 5G, Carmen, that makes us very hopeful for the future and for this deployment. Before talking about the future, let's start with the first round of table, and I would kindly ask the panelists to tell us about what has been done in the past, therefore, and especially the information about the decision made within 5G, Carmen, which was that of making research using the existing infrastructures and also in weather conditions that were not always ideal, using the commercial infrastructure that was there, which was not theoretical. We did not work in a lab. We worked on the field, and in the field. So that is what I would like to start with and from. And the first speaker will be Alessio Beltrame from the Ugo Bordoni Foundation. He's in charge of innovation and development there. And the foundation supports local administrations and public administrations in general in supporting them with knowledge about digital technology. So public governments and administrations receive this digital support thanks to the work performed at the Ugo Bordoni Foundation. What do you think about 5G, Carmen, in terms of the main goals and results also? What about this idea of bringing together the research and the practical and already existing infrastructure? Thank you very much for inviting me, first and foremost. Our foundation has been an observer, actually, of the project. And with the Ministry for Economic Development, we have already, we have, of course, seen to all projects and experiments pertaining to 5G. Within 5G, experiment and research play a fundamental role in preparing future deployment. This is something that emerged very clearly here this morning. You told about the problems found and tackled. This, of course, paves the way to the tackling of the challenges ahead, because this project has not covered all aspects. It has been said there are still aspects which need to be analyzed in order to get to a deployable project, an executive project. The Commission told us that we needed to hurry up. we need to be very fast. We need to run. And I really believe that the main positive aspect of this project, leaving all technological aspects aside, is the fact that the project has brought together all actors in the field, all stakeholders, all those who are involved in the sector of mobility. Clearly, if actors are not fully represented, you will never have something that you can really deploy. 5G is peculiar in that respect. 4G, it has been said, meant connectivity, a huge availability of data, and making that available to everybody, while 5G is more selective and it works with the verticals, as it has been said. This is the one vertical, mobility. But in general, we also talk about port, airport, railway stations, and then farming, tourism, smart cities, industries, factories, the manufacturing sector. There are several verticals where the involvement of the other stakeholders is key. In order to meet objectives, 5G needs to cover a number of complex issues, which also require huge investments, which differ depending on the type of service that I want to achieve. If I use assisted level 4 and 5 driving, which is fully automated driving, you need to have a thorough infrastructure. You need new towers. The edge computing has to be as close as possible to the place where data is generated, because you need to make decisions immediately after analyzing huge quantities of data in order to be safe. So the edge computer has to be very close, and this has to be multiplied for all sectors that I mentioned, which entails investment. Telecommunication operators in general have been asked to invest in connectivity. So the question is, are they enough? Do they suffice in relation to the infrastructures that have to be built, investments that are required by that? I think that we need to involve a broader group, including those who have concession agreements for the infrastructures, the operators, therefore, of infrastructures, and all those who have a vested interest in making this operational and fast. The challenging objectives have been voiced by the representative of the European Commission, and I would also like to recall what Mr. Profumo said when talking about the need to bring together several entities, connectivity, transition, a transition which needs to move in a sustainable direction, so towards sustainability. That is the slogan. And we also have the accountability and responsibility of state and public entities, which have, of course, therefore, to be involved. This is what 5G stands for. 5G Carmen, stands for. And I think that that was the key positive feature. Thank you, Alessio. Thank you for recalling the need to involve all actors in the supply chain, so to say. And we do have all actors here today at this table. We have two representatives of the supply chain at the very edges. One person coming from the academic world, and then the representative of INWIT that manages the towers, the antennas, and that therefore hosts this technology. We now start with Andrea Mondo from INWIT. He will address us on the aspects that are fundamental in order to have a 5G Carmen work. I would like you to comment on what Alessio Bertrame said, and also on the thing that I said, the fact that we performed research using actual infrastructure. Well, good afternoon. I'm very happy to be with you, albeit remotely. what Dr. Beltrame said is absolutely correct. We speak about ultra broadband and the deployment of optic fiber and 5G, which means enabling elements behind digital transformation, which is a pre-requirement for digital revolution transformation. The point now is how enablers can become practical entities. What we talk about today is an extremely important case, which I hope will set an example for industrial development in the future. What was an issue of technological readiness until a few years ago, by now has been solved as an issue, or at least it is being solved. The point now is to see how the various verticals will make the investment possible to achieve a real digital transformation. There are several players in this. We feel to be an enabling entity behind the transformation and transition, because we are present throughout geographically, and also because we are present where communities and where manufacturing entities are. We need to develop ad hoc investments and use cases depending on where you act. Today, an enabler today in terms of communication and data will be tomorrow an enabler of the digital communication. This entails having the right sensors, having the right devices, equipment. And here I agree with what Mr. Beltrame said in relation to edge computing. We will have to make decisions about locations there based on the local specificity. This is not only an industrial change. Industry 4.0 is what we talk about, automated industry and remote management, supply logistics, and management of local specificities. We have drones that are enabled on the towers and that make it possible for us to control an area, and we also have to supervise the environment. So these are all elements that make it clear that you have to make a specific investment depending on the local use case. 5G is an enabling element, but you also need to bring the optic fiber to the tower. And the next step will be that of developing use cases to develop the digital transformation, which is not only limited to the industrial sector. Also, socio-cultural element will have to be transformed and will have to be there. In addition to having to address the environmental aspects, and this goes with sustainability, we will need to change our habits, and this has to do with culture. So I agree entirely with what Mr. Beltrame said.
Thanks a lot. So let's go to the other end of this virtual supply chain represented here, in particular Professor Klaus Pahl. Thank you very much for being here. Klaus is the Dean of the Faculty of IT Technologies and Sciences, and together with the Bruno Kessler Foundation, the Turin Polytechnics and the university, is one of the partners, Italian partners in this project. So I'd like to have your point of view from a point of view of a scientist, let's say. So I need to change language.
My Italian isn't good enough. I'm here for a while in Bolzano, but again, on the technical level, I prefer to use English yet. So the perspective of the universities, clearly this is a benefit to us to learn, and particularly 5G Carmen, I think is characterized by two important dimensions for universities, but possibly for all the partners involved. Firstly, this is a clearly multidisciplinary setting. So we have the car manufacturers, we have the telecommunication companies, hardware providers, up to the software solution there. And this is important to learn from each other. But one particular, let's say, trend that is kind of in this space kind of signals even the need to bring these together. So there's clearly this kind of convergence at the moment that brings, let's say, the telecommunications people upwards towards, and there would be terms used like softwareization, virtualization, being used to bring this more into my area, computer science world. But I can also see, and I'm coming from this wider cloud computing area, where we need to get closer to what is distribution, to what is networking. So we see this kind of conversion, things that were often treated separately. And in English, and I think it even works even in Italian, well, we have all of these big C words: communication, collaboration, computation, control, and all of this kind of merges into one space that we need to now jointly address. So 5G Carmen was simply a way of bringing these competencies together to learn from each other and then bring this forward into the future. I also mentioned this other dimension, which is important for us and as university or as research partners, to show our responsibility for, let's say, the society as a whole. The EU likes this term of TRL, so technology readiness levels, and we typically, obviously, as research institutions, sit at the lower end of this. But here we can really learn what makes the difference to bring this into practice. And actually today we really see this, the effort that goes into bringing technology into, even at the demo stage today, to bring all the partners together to make this work. And also to take a, let's say, a take-home message from this is and we heard it, I think Roberto Fantini mentioned this in his kind of research summary, that there is a difference between what you do in the field, what you do in reality, compared to what you can do and achieve and learn in the, let's say, the lab environments, in the test bed. And maybe to map this into the future a little bit, I think this is what we take home is as research institutions, but maybe also the other partners, is this need for, okay, we already relied a lot on simulation here, and this was partly caused by COVID, not being able to come here and go across the borders in certain periods when we would have liked to do this. But what comes out of this is this kind of the whole digitalization of the world around us. And I might want to bring the term digital twins there. I think we need to move closer to not just kind of simulate and simulate the kind of the performance, the latency aspects of systems, but to have a holistic perspective and to be able to not only to monitor, but to analyze, to maintain complex systems by having this complete digital twin somewhere that we can operate irrespective of whatever is the condition in the real world. So there was a lot for us to learn, and as a computer scientist, of course, steps that are ahead of us is this notion of, let's say, intelligence that we need to bring forward, and maybe also to remind you of a picture that you've seen in the research summary, where there were this architecture, these kind of blocks of things on the mobile edge cloud, the MEC layer, where we've just seen terms like orchestration, and we were all hidden from the complexity of this. So if we zoom in, we would have seen lots of orchestration links between various different layers, and this is where we see this kind of mix of computation, communication, bringing us closer, using virtualization from the radio access network layer up to the mobile edge clouds, to the decentralized clouds, where this now becomes this big space that we need to better understand, firstly, but also better maintain. And there, I'm hoping this is, again, one of my take-home messages there as an academic, to use this kind of pervasive intelligence approach and make everything smarter, to predict, to see problems coming before they actually occur. Again, if I can pick up on a word that Filippo earlier said on the, let's say, we need to look ahead, we need to see what's not just kind of physically beyond the lorry or the bend on the road, but also in time we need to find out what could be a problem before the problem really becomes a problem.
Perfetto, grazie mille. Devo dire che tutti...
Well, thank you. Everybody, well, when describing the results of the project, I've already talked about the future, but in my second round of questions, I'd like to focus on the future further because the future is close and we have to do a lot in a limited amount of time. There is a high level of expectation, and so we have done a lot in this consortium, and it would be a pity if all these that has been done, it would be a pity if it went lost. So Klaus, I'd like to start from you. Do you have ideas on considering further developments and evolution of this project? Well, of course, stressing the role of the academia.
The word digitalization has occurred now throughout the morning several times. So digitalization of infrastructures, what has been in telecommunications, mainly really physical hardware, becomes software now. And then software becomes essentially or needs to deal with data. I think I see a big issue around the management of data, be that data that we need to communicate the car's positions, their velocity, their intentions, but also data that we need to know about, let's say, the infrastructure, how well is the infrastructure managing all this is doing. So data becomes a central issue, and we need to learn better how to deal with data in this space. And I already mentioned this idea of pervasive intelligence. Data now appears at the edge, at the network level, and not anymore centralized in big data centers. So we need to bring intelligence to the data, and this is one of the great challenges, because we've seen, and this is one of, again, the outcomes of 5G Carmen, data needs to be processed under very, very critical latency and also reliability issues if we think of the autonomous cars. Another issue that plays into this is the security side or the privacy. So we have data that needs to be processed, that needs to be gathered, analyzed, and put into a kind of fruition, into some positive benefit under all of these reliability, safety, and performance issue. And for that, we need to kind of develop, again, more intelligent technologies, and that we can even bring into to the edge, and also considering privacy concerns. So machine learning is a big thing in various domains, but we need to make this really also alive in this specific space of edge computing. So we need, again, terms being used like federated learning to make clear everything needs to happen in this kind of high performance and high security awareness space.
Perfetto, grazie mille. Devo dire che come collega, diciamo, del mondo della ricerca mi trovo molto sui commenti fatti.
Well, as a colleague, I absolutely share your point of view, and I think this is a very important direction for the future. But now I'm curious, I'd like to hear what a tower operator suggests in terms of how we can further evolve the 5G Carmen, this and the innovative and its innovative nature. Well, first of all, we should, of course, ensure that the ultra broadband covers the entire territory, and so we will have to find the technical way to ensure a priority access to radio resources and redundancy, because this is a typical service that is zero fault tolerant, so is not fault tolerant at all. So we have changed the standard a bit so as to avoid latency time and So we still have to do something in terms of coverage, but then security is important. But this huge volume of data that can be exchanged has an element of proximity in the tower in terms of edge computing, mobile edge cloud. They can run. You can avoid running too much data at a remote level. So the tower is looking forward, could become not so much a mini data center, but could have some processing features, and together with nearby towers, they can exchange data and can become a bigger cloud-based cloud. So then, in terms of timing, the deployment of these of all these should be facilitated, because our ambition in terms of timing should be be supported by regulations, and I think that we should work together with the institutions to have this combination, let's say. Thank you.
I will now conclude the second round of table addressing Alessio again and the Bologna Foundation, because you are a third party, so to say, vis-à-vis the project. We have worked together, of course, but you enjoy this third-party position, and being it so, you can give us all the more suggestions. Could you give the partners in the project suggestions about the way by which we can implement all these and make it real in the next years? Here, I would like to go back to what we said earlier on about the need to involve all stakeholders and actors in the supply chain. They should also be aware of the fact that no one plays alone. This goes for all sector, and all the more so for this one. You can't have an automotive player going in one direction and another car producer going in another. Of course, each company wants to have a return on the investment and wants to have a profit. I believe that there is a business here if we join efforts, if we work together. That is an awareness that we all need to develop. We feel closer to the public, to the state sector, because we are part of it. Basically, we come from there. This is what I mean. But you see, also in relation to the Recovery and Resilience Plan and all the other resources that have been made available, they are huge, this amount, and we need to be very clear about what we want to do with these resources, with this money. You see, the Recovery and Resilience Plan has a sort of a silo approach by sector, by ministry, and that is something that I criticize. Digital is something that applies to all ministries. You can change name to it, but it is something which is enabling all sectors in all ministries, which means that we have huge amounts of money at our disposal. Let's use them. Let's invest together, sharing projects. What can happen in the private sector can also happen with public entities at national and local level. The latter perform a fundamental role. We said that 4G was something which was very much consumer-oriented, while 5G is very local, meaning that it wants to develop local networks and local areas, local sectors, individual sectors. There can be the possibility for these local entities to invest, and we need to find a way to stimulate them and to spur them to do so. it is a different logic and rationale here. We need to invest in infrastructures, as I said, and that is not easy when the public entity makes an investment. The public sector has financed, for instance, the fiber connections at the stations, and the white areas have been funded and financed in relation to a general coverage service, thinking in terms of throughput. If we now consider where these white areas are located, where we have shortages vis-à-vis rural areas or road infrastructures and other types of services, then we find other levels of white areas, which means that we need to have this central and local capability of acting, of interacting with the European Commission so that it also finances infrastructures. In addition to that, we need to fund and finance services. 5G Carmen-like actions and initiatives must become operational, and this requires that we implement services and that we finance them. Of course, that goes hand in hand with the financing and funding of infrastructures. Without infrastructures, you can't achieve anything. That is clear. So this is the recipe that I think we have to bank on. Joining efforts, being part of the same system, sharing projects, and then individual players and entities being able to make their part also through urban and economic planning activities, because that can make a difference at a local level, and competition between areas is a healthy thing. It should be there. There can be a positive repercussion and positive best practices then drive the other areas as well. As I said, I wanted to be brief, and we indeed have been brief. Thank you very much to all the speakers for helping me in this endeavor. Now I would like to give back the floor to Matteo to draw conclusions. I'm sure that Matteo will thank all the others, but I thank Matteo for this huge amount of work that he has put into creating this network of cooperation. Also during the pandemic, it was not easy. Thank you. You met the challenge, wonderful. And you also worked so much to organize this event. And now there is the demo. So thank you. Thank you very much for your work. A round of hand to you and for you. And now you can conclude the meeting, Matteo. Well, I would like to conclude by thank you all. I would like to thank the panelists of the round table. I would like to conclude, as I started, by thanking a number of people. As I said, the speakers, not only of the round table, but all speakers, thank you for your contribution. Thank you for bringing your vision and sharing it with us. I would like to thank the Bruno Kessler Foundation people. Without the communication and events department, we would have never made it. And then thank you to A22 for hosting us and for organizing the day. I would also like to thank all our guests, as is the case with Mr. Spinelli from the Autonomous Province of Trento and Tito Mari representing the ministry. So, Vito Mauro, sorry, for representing the Ministry of Infrastructure and Transport. Thank you very much. This is the end of our meeting, and those who are physically present here now will be lucky because they can indeed participate in the demonstration on the road.